EVS Pandey, your physics lecturer. Today, my dear students, we will study about speed and velocity, and we will see basically the average form of this speed and velocity. All right. So let me start today's lecture. It is lecture number 20 of standard 11. Okay. So it is lecture number 20. Kinematics, and we are studying here the one-dimensional kinematics. Alright, my dear students, the topic we are going to start today, it is speed and velocity. Alright. We will represent the speed, my dear student. It is with the v, it is scalar quantity. Then we will use the velocity as a symbol. It is the vector v. Alright, it is scalar quantity, and this one is the vector quantity. We have studied about the path length, that is this distance and displacement. Okay, we will use that concept also. Alright, my dear students. Speed, actually we used to represent the speed as you have been studied in your standard 9th, my dear students. Okay, so the speed, it is the path length covered in particular time interval. It is the path length over time interval, or the time taken by the body. Alright, is SI unit will be meter per second. Remember, it is scalar quantity. We don't require any particular direction for its representation. Now, the second one is the velocity. As I told you, the speed we will represent by v. Alright, and the velocity will represent by the vector v. It is shortest path length. Shortest path length. Of course, we are talking about the displacement divided by the time taken. Time taken. Alright. So this is a velocity. And this velocity will have the same unit. It is meter per second, because it is also the path length per unit time, and the symbol we'll use here, it is v vector. Alright. Now its type, my dear students. Its types are, basically we'll focus over the average velocity and instantaneous velocity in today's lecture, but we can discuss the three types. It is uniform speed or velocity. Simultaneously, we'll study both the quantity to save our time. Alright, uniform speed and velocity. The second one will be the average speed and velocity. Alright, and the third one, it will be the instantaneous value. Instantaneous speed and velocity. Alright, yes. So my dear students, one by one we will study all the three types of speed and velocity. As I told you, the speed, it is the path length per unit time, the very simple definition, and the velocity, it is the shortest path length per unit time. Here, about the uniform speed or velocity, actually my dear students, this word uniform also refers to the constant. Remember, constant, which is not changing, and this uniform, that is the constant, speed or the velocity, it is quite obvious with this particular term, the speed will not change. Actually, the particle which obey the motion with the speed which is constant, or the velocity which is constant, it refers to the uniform motion. Remember, uniform motion. We will study in very detail the nature of the uniform motion. We will study the graph, what will be the nature of the graph while the uniform motion having the particle of the body. Alright, so the uniform motion. What does it mean, the constant velocity of the uniform motion? Of course, the velocity not going to be changed. For example, suppose a particular person here want to start moving from here. Alright, yes, and it cover equal intervals. Alright, equal distance, sorry, 0 meter, the 5 meter, 10 meter, 15 meter, and then it is 20 meter. But taking, this is the distance or the displacement, and taking equal interval of time. Here 0 second, but it reach in 1 second, 2 second, 3 second, and 4 second. So this is called the uniform speed. If you find the speed, that is the length covered in 2 seconds, then you will find the total length it covers, how much it is, 10 meter, and time it took 2 seconds. Alright, it took 2 seconds, so it is the 5 meter per second. If you will try to find out the speed of this motor, my favorite character, it is motor. Alright, yes, motor. The speed from here to here, you will find the total length it cover 20 minus 10 is the 10. You can see it is the 10 meter from here to here, and the time it took, how much, 4 minus 2, it is the 2 second again, and it is 5 meter per second. Okay, so you can see the speed is constant. If you try to represent this particular things over the graph, my dear students, then you can plot over the graph as well, like this way. We will try to plot over the graph. We can plot like this way. Here, this is the distance and time graph. This is our origin. Suppose the marking of the time we are giving here, the 1 second, 2, 3, and 4 second. The distance it covers, motor covers actually the 0 meter, it is the origin itself, 5 meter, 10 meter, 15 meter, and 20 meter. So it is the 5, 10, 15, and it is 20 meter. Yes, at 1 second, motor was at 5 meter. Okay, the first one is the origin itself, but at 1 second it was at 5 meter. At 2 seconds it was at 10 meter. The marking should be correctly. You should use scale for the proper representation. The 3 seconds it was at this length, and the 20 it was at this particular length. If you try to match this all coordinates, you will find here a straight line like this way. Okay, now this is the average this is the constant speed representing by this graph. This is the constant speed, and this type of motion is called uniform motion. This is the graph of uniform motion. Now my dear students, if the question is coming in your mind, sir, whether this one is also the uniform motion, if this graph will steeper, it will goes towards the x-axis, that is along the time axis, whether this will be the uniform motion. Yes, my dear student, that will also the uniform motion. If we are representing the graph like this way, this is the x and t, the graph is this one, then this is also uniform motion. This one is also uniform motion. But for both the graph, slope are different. What does it mean by the slope, my dear students? In mathematics, you will study the slope. It is basically the tangent. Okay, you will study basically the tangent, the slope, concept of slope. you will study that slope is nothing but the base. This is the time. The slope is it is represented by m, okay, and the slope is the base, sorry, perpendicular, that is the height, with respect to the base. Alright, suppose if you draw a line over here for this angle theta, if you're finding the perpendicular, of course this would be the perpendicular. Alright, suppose it is h and the base, it will be this one. Alright, this is the h by b, and this you can write it the perpendicular by the p also, if you are very familiar with the coordinates. Now this is p by b, and this is called the slope. Of course this line having the greater slope, line A and B, line A having the greater slope with compared to the line B, and this particular slope gives you the quantity here, it is speed. It means the slope of distance time graph, the slope of distance time graph will give you speed. How? Try to find out. M, it is a slope, perpendicular. You can see here the perpendicular. Let me draw another graph of distance and time. Okay, here I am drawing a perpendicular. It is the time, of course, this will be the time, and this line will be the, which is parallel to the distance, so it will be the distance. We are considering the slope. So my dear students, the m, it is nothing but the tan theta, will be the tangent. This perpendicular base is also considered as a tangent, which is the slope, tan theta. So this tan theta will be the perpendicular. Here it is nothing but the distance, and base, it is nothing but the time. So you can say this is the speed. So remember, the slope of distance time, gives the speed. Okay. Directly, if you're having a graph and using that graph you have to find the speed, then you can write the slope is the speed. If I'll ask, using this particular graph, x, t, this x is the distance and t is the time, the two graphs have been drawn here, graph A and B. If I'm asking which vehicle moving faster, then you can say this slope of B is smaller than the slope of A. Here the tangent, that is the m of A, it is greater than m of B. It means the speed of A will be greater than the speed of B. You can also find, as we know that this theta will increase, the value will increase. Here the tan theta, the slope is nothing but the tan theta. If tan 0 is 0, then tan 30, it will be 1 by root 3. As you will move, tan 45, it is 1, and tan 60, it is root 3, more than 1. It means increasing the angle, the tangent value increasing. Of course, the slope is increasing. It means the higher the slope, higher will be the speed or velocity. On a straight line, if you are moving, then if this is velocity, displacement, then this will give you the velocity. All the quantity remains same, this becomes the velocity. Remember student, here we teacher actually helping you to understand the concepts. Remember, don't run for all the topics covered over the board and by the teacher. Try to get practice by yourself also. Okay, so try to understand the physics, core of physics. Here, this is the slope and the concept of slope I have discussed. Now, my dear students, if we are talking about the uniform speed, and we have seen the graph of uniform speed, let me draw here a few graphs and you can guess what are the quantities it is represented by this particular graph. Okay, now suppose again want to start moving from this particular point. It is 0 meter, 5, 10, 15 and 20. Alright, yes, but motor moving like this way. Motu moves, let me write here the OA, B, C, and this is D. Motu moves from O to first C, then it return back to the B, and then to D. And remember, the motion, it is uniform. Motu moving with uniform motion. It means for each 5 meter it took 1 second. That is the equal time interval. I have not given you the definition of uniform motion, my dear students. You can write, if the particle cover equal distance in equal interval of time, then the motion of the particle will be considered as the uniform motion, and the speed must be constant. Alright? Yes. Now, we are going to draw here the graph of distance time and the displacement time. The two very important graph we are going to discuss over here. The xt and x vector t. Remember, this is the displacement time and this is the distance time. Okay. Now, in the origin, let me write here the quantities. I'm trying to mark here at the equal interval of time. I'm not very much well in drawing, so might be the marking may differ. Alright, here is 0, 1, 2, 3, 4 and 5. The lengths 5, 10, 15, 20 and 25. 1, 2, 3, 4 and 5. Here 5, 10, 15, 20 and 25. Alright, this x is considered in meter, this also considered in meter, this is considered in second, this time, and this time is also considered in second. Alright, this is very important. When you are giving the parameters to the quantities, you should mention these things. Alright, now we are going to represent here the motion. When motor moves from O to C, it covered total 15 meter and took how many seconds? 1, 2, 3 seconds. Alright, in 3 seconds it moves 15 meter. Alright, the first coordinate we got. Now, it moved back and cover how many? It cover 5 meter more. Already it was 15 meter, so 5 meter will be added or subtracted. No, it will be added. Distance never be negative, so it will be sum up always. So it is the 15 plus 5, it is 20, and it took how much time? 1 more second. So it is 20 and 1 over here. You can see. Now more to get back, return to this point D and cover how much distance? Already it is 20. Now it has to move 10 meter more. That is the 30. We don't have the scale up to the 30. Let me drop right here the 30. And the time. Yes, the time it was the 4 second already. Here the 4 second it took 3, 1, 4. Now 5 and 6. So I'm hanging here at the 5. So the 6 will be somewhere a little more further. And when you will draw the graph over here, you will see the nature of this graph looks like this one. This is the uniform motion. Okay. Now come to the displacement. You can see here the slope is always positive. Everywhere you will draw the slope and you will get here the slope is positive. It means speed always positive because slope is positive everywhere. Now look at here. If we go to the first point O, here go point C, 15 meter in 3 seconds. Alright, the 15 meter in 3 seconds to this point. Very good. Now next, if the particle over here, the motor over here, how much displacement will be there? How much? It is 10 meter, but time will not decrease. Time will add up. 3 plus 1, 4. In 4 seconds, the displacement it is 10. So the 10 in 4 seconds, like this way. Alright, so move2 goes in this way. Yes, it goes like this one. Now after that, move2 again move to point D, and the total displacement you will find it is 20 meter. So move2 goes in 6 seconds. Over here. Now we will consider the slope, my dear students. Here we find the slope. Of course it is positive. Here also we are positive. After that, you can see, my dear students, here the slope is negative. Why? The theta is negative. You can see here the theta is negative, minus theta. If we move from this axis in this direction, theta is positive. If we are moving in this way, then theta is negative. I hope you have studied in mathematics. So if we are moving downward, it is negative. So you can see this one is the negative slope. It means if you are writing this A, B, C, alright. So from A to B in graph, remember, don't focus over here. Okay, let me write in the PQR. PQR. Alright. Now from P to Q, slope is negative. From P to Q, M is negative. It means the velocity will be negative. It means velocity could be positive, could be negative, and 0 also. So you can see here the velocity negative. Why? Because it reverse its direction. So this velocity may be negative. It is the vector quantity. Okay, my dear students, using this particular graph, we have studied how the velocity and the speed never be negative. Remember, if particle reversing, it changing its direction, then also the distance will be same. The distance will not decrease anymore. Okay, my dear students. Now, so till here we have covered the speed. It is distance by time, alright, and the velocity, it is displacement by time. The two important formula we have discussed till here. If it is constant, that is by t, it is constant, or this displacement by time, it is constant, it means this is uniform motion. Okay, now we'll move to the next topic. It is average speed and velocity. Alright, we'll represent the average speed and velocity by this symbol. This is the average speed and this will be the average velocity. Alright, my dear students. So first you will write the definition of this average speed and velocity. The average speed, it is the total distance traveled by the particle in total interval of time. So we can write the average speed, it is the total path length by total time interval. Alright, and the velocity, net shortest path length, alright, by total time interval, that is the total time taken. We can write this as delta x over delta t, and this could be written as the delta x vector by delta t. Okay, my dear students. This delta actually here representing the total value, but later on we will study this could be also considered the change. When we will study this average speed and average velocity using the coordinate. Okay, so this one is the definition of the average speed and velocity. My dear students, if you will find this formula in few books like this way, average speed, it is the sum of the length over the sum of the time. This is also correct. Okay, don't think so. What is this one? So this is the summation of x, it is the total length, that is the total distance, and this one is the total time interval. Alright, yes. Now here a few examples. Suppose again this mode to cover x1 length in time t1 and x2 length in time t2. Could you write the average speed of this motor? Oh my god, where is the hand? Yes. Could you find the average speed of motor? Yes, you can find. How? The average speed can be written as, it is the total distance, that is the x1 plus x2 divided by total time, it is t1 plus t2. Am I right? Yes, it is the total distance by total time. In this way you can find out the average speed. Okay, now I am going to change the condition and you have to tell me the average speed. Remember my students, if we are moving on a straight line, remember, if we are moving on a straight line, then in that case the average speed and average velocity will be same if direction of the particle is not going to be changed. Alright, yes. Now the next example. These are the different type of question, my dear students, that you will face in competitive examination. Alright, yes. Now the next question, and this question is telling, suppose motor cover its entire journey, it is A, B, motor start covering its entire journey, the half the journey with the speed v1, alright, and the rest half journey with the speed v2, then what will be the average speed? The question is, what will be the average speed? Try to think. Could you solve this question? Remember students, here the time is not given, but in question it is given, if half the journey is covered by the v1 and half, that is the rest half journey, is covered by the v2, then what will be the average speed? Okay, let me solve this question. We don't have time. Suppose the time t1 and here the time t2. Okay, so could you write the time is the distance by speed, and distance is null by the s by 2, and the speed is v1. So here t2 will be the distance by speed, it is v2. We don't have the value of t1 and t2, but we have calculated here. Okay, now the average speed v is equals to the total distance. I hope that black marker is more visible, much better visibility. The total distance, how much it will be? The total x by 2, and x by 2 it will be the total x, and the total time it is the t1 plus t2, which we have been already calculated over here. In the x divided by x by 2v1 plus x by 2v2, this will be cancelled out, and you will find here, taking the LCM, here the over n, the twice v1 and v2, v1 plus v2, am I right? So the average speed we are having 2 v1 v2 by v1 plus v2. You can see again we are having the unit meter per second. It is meter per second, and it is meter per second, and it will be the meter square per second square, but here it will be the meter per second, so the overall you will get meter per second. If half journey covered with v1, another half journey covered with v2, then in this way you can find out the average velocity, my dear students. And remember one thing more, if it is not the half journey, if it is except any other distance, any other journey, you can find out using this formula. But this one is for the half journey, twice v1 v2 over v1 plus v2. Now one question I am giving you for your homework. Alright, so write down your homework. Here the homework. the first homework of this lecture. If I hope you are writing the question, my dear students. If 1/3 journey it is cover with, if 1/3 journey cover with V1 and the rest journey cover with V2. Alright, 1/3 covered with V1 and the rest journey it is covered with V2. Then what will be the average speed of entire journey? Okay, my dear students. Alright, now the next example. Look at here carefully. I'm going to solve here the next example. Again, Motu moves from A to B. But now, what he is doing? Motu moves half the time of entire journey, half the time. Okay, T by 2. Half the journey with speed V1 and the rest half journey with the speed V2. Now you have to find the average velocity and the average speed. We are talking about the motion on the straight line. Could you find, my dear students? If you can find, try to find it. Okay. Now let me find here. We know that suppose the distance here not given, it is x1 and here it is x2. So could we write here the time or the distance x1, it equals to speed into time, that is the V1 into T by 2, and here x2 it is V2 T by 2. Alright. Now according to the formula here, the V it is equals to x1 plus x2 divided by total time. How much it is? T by 2 plus T by 2. Now x1 it is V1 T by 2, we are having the common, plus V2 you can see divided by T, cancel out. So V1 plus V2 by 2. This is the average speed. Am I right? Yes, this is the actual answer. Okay, one question, an interesting question, let me discuss from engineering examination. Okay, let me grab this one. Student, if you find any trouble in my lecture, you must ask in group. And another thing, if you find any calculation error, let me know in the comment box. Alright. Okay. Now this is the question, my dear student. Look at here. A very interesting question. A particle goes in this way, the semicircle, if the radius is r, but the particle is going from this path with the speed v. Remember, v is what? Uniform speed. It is the uniform speed. This is the point A, this is the point B. You have to find average velocity, okay, from A to B. You have to find the average velocity from A to B. If you can solve, kindly solve this question. Solve? Okay. Let me solve this question, my dear student. We know that the average velocity, it is the total displacement at the path length by total time. How much the total path length? The shortest path length, the next shortest path length, it is this much. Alright, so it will be the diameter. I think this is 2r. Now, what about the time? How much time it took? So here we are having the concept, it moving with the speed v. Alright, so we can find here the time. How much distance is going to cover? The radius is given. Then it means he has to cover how much? Pi r. How much length? Pi r. But with which speed is moving? With v. So we can find out the time covered to this half circle, that is the semicircle, and it will be distance by speed. So we got the time also. We have to put the time over here, and we got the value of this delta x vector. It is 2r. Then you will have the answer. I hope you understand, my dear students, the 2 r divided by pi r over b, 2b over pi. This is the answer. Am I correct, my dear students? Yes. Kindly note down, pause the video and note down this one. Okay. Now, one more question. Okay. So we are discussing here the average speed and velocity. Now, my dear students, this question I'm giving you for your homework, because we are running out with the time. I'm giving you this particular question for your homework. You have to solve. Next day we will start the instantaneous speed and velocity. Okay, my dear students. So this is your homework, another homework. And this question mentioned in SC Burma, alright, and few interesting examinations. Here the three particles are at the three vertices A, B, C. Alright, you can say the three kids are playing, standing at A, B and C. It is equilateral triangle. Suppose the length it is A, the side it is A equilateral triangle. But all the kids decided to start running at the same time, simultaneously. Okay? Yes. They have to move simultaneously and they willing to catch each other. It means its target to catch this particular boy B, and this boy B as a target to catch the boy C, and C is trying to catch the boy A. Alright? And all boy decided to move with the same speed. Remember, this is all calculated. It's moving with the same speed V. V is the uniform speed. They don't have to cheat each other. Now the question, if all the three boys start running, where and when they will meet each other? When and where? You have to find position and time. Alright. When and where they will meet each other. Okay. So, this is your homework. You can convert this question also. I don't remember how many homework I have given. Here the next one. You can also convert this question in square form, in hexagonal form, in any other form. This is the side A, this is the side A. All the four boys moving with the same speed V. Alright, yes, all decided to move simultaneously and willing to catch each other. Okay, when and where they will meet each other, and when they will meet each other. Okay, you have to find time and position. Time and position in this case also. The number of questions are given. If it is given as hexagon, the 6 kids are standing here, here, here. Alright, here they start running to catch each other. Where they will catch each other is the size A. So there are a number of questions like this way. If you will understand and if you will be able to solve this question, then you will be able to solve all the questions. Okay.